Hello again. This is Math 2231 coming to you from the College DuPage. And the title of this lecture is Analytic Geometry Review. And as always, please be an attentive learner while watching this video. Success in calculus depends to a large extent on knowledge of mathematics that precedes calculus. We've already covered algebra. Today we do cover analytic geometry. And so after each test, you can check your answers against the given answers and if necessary, refresh your skills. Again, once we begin our calculus run, we will review just in time and within the context of the problems that we are addressing. First problem is here. You want to find an equation for the line that passes through the point 2, minus 5 with a slope of minus 3. The one that passes through that point parallel to the x-axis, the one that's parallel to the y-axis passing through that point, and passing through that point parallel to this given line. You should give this a go, and when you're finished, check the answers. Let's see how you. Well, if we have a point and a slope, we know that the point slope formula line y minus y1 is equal to m times x minus x1, where x1, y1 is the point that we're given and m is the slope. So if we apply that to the point and the slope given here, we get y plus 5 equal minus 3 times the whole of x minus 2. If you simplify that into a different form of the line, the slope-intercept form, you get y is equal to minus 3x plus 1. Parallel to the x-axis means that the equation is the form y equal constant, and there's a slope of 0, so y is minus 5. Similarly, parallel to the y-axis means we have what is called an undefined slope, and the equation is going to be x equal 2. And if we're parallel to this line, we can solve for y, as we did here, find out the slope of this line is 1/2. Then we can use the point slope form as we did here, and we can find the equation of the line is y equal 1/2 x minus 6. Our next problem is find an equation for the circle that has center minus 1, 4 and passes through the point 3, comma, minus 2. Again, you should pause the video, give this a go. Let's see how you did. Well, the equation for a circle is of center hk of radius r is x minus h whole squared plus y minus k whole squared equals r squared. Given the radius, then one of these is the center, the other is the point. So the distance between these two, using the distance formula, is the square root of 52, and that means that r squared is 52. So applying the equation of the circle to this, we have x plus 1 whole squared plus y minus 4 whole squared is equal to 52. Number 3, we're to find the center and radius of the circle with the equation given by x squared plus y squared minus 6x plus 10y plus 9 is equal to 0. Again, you should try this, and then we'll see how you do. And now, let's see how you did. We're going to be completing the square on the x by adding a 9, and completing the square on the y by adding 25 to both sides. And then we're going to then observe that this is x minus 3 whole squared plus y plus 5 whole squared equal 25. That means the radius of this circle is 5 and the center is 3, comma, minus 5. There's several problems that are part of 4. So you take points A and B. You want to find the slope of the line containing A and B. Find an equation of the line that passes through A and B, and also answer what are the intercepts, x and y intercepts for this. We want to find the midpoint of the segment AB, the length of segment AB, an equation of the perpendicular bisector of AB, an equation of the circle for which AB is a diameter. Again, you should try this on your own, pausing the video. Let's see how you did. Well, the slope of the line is going to be y2 minus y1 over x2 minus x1. So we find the slope here and we get minus 4 over 3. In part B, we could use either point, but we're using this one, so we know this is the slope. So it's y minus the y coordinate is equal to m, which was minus 4/3, times x minus the x coordinate, and we get this. And we could simplify this in several ways. Here it is in the slope-intercept form, and here it is in a different form. This form is particularly useful for finding the intercepts. If I set x equals 0, I get y is minus 16 over 3. If y is equal to 0, I find that x is minus 4. Part C, we use the midpoint formula, which is adding the x's together, dividing by 2, and adding the y's together, dividing by 2. If we do this, we find the answer is minus 1, minus 4. Here we want to find the distance between these 2 points. We use the distance formula, and so this is the square root of the difference between the x coordinates whole squared plus the difference between the y coordinates whole squared, and the square root of 400 is 20. Now, the slope of a perpendicular line is, assuming this is not equal to 0, is the negative reciprocal. So since the slope was found in part A to be minus 4 over 3, the slope of the perpendicular line is 3 over 4. And the midpoint was this. We found that in an earlier problem. And so it's going to be y minus the y coordinate is equal to the slope of the perpendicular line times x minus the x coordinate. And so I could write it this way, or I could simplify and write it this way. Now, that AB is a diameter means the length of the radius. We already found that this was 20, so the length of the radius is 10. And so this is the center of the circle, and so the equation is x minus the x coordinate whole squared plus y minus the y coordinate whole squared is the radius squared, which is 100. On number 5, we're to sketch the region in the xy plane defined by the equations or inequalities, and you see we have several examples here. Again, you should try these on your own, and we'll return in a bit to see how you do. Let's see how you did. Well, here the y runs from minus 1 to 3 inclusive, so it's all points and the lines are solid. Here, the absolute value of x being less than 4 means the x values range between minus 4 and 4, and notice the boundaries are not included, and, meaning both of these, the intersection, the absolute value of y is less than 2, and so it's in between the two, and so these are dotted, but it's this dotted rectangle. Here, you're saying that y, the y coordinate, is less than the line whose boundary is given by y equal minus 1/2 x plus 1. And so that line is dotted and is the y values underneath that one. Part D, it's the y values that are bigger than or equal to the equation that's given by y equal x squared minus 1. So here the solid boundary is y equal x squared minus 1, and it is the y values that are above that. Here it is the interior of a circle centered at 0, 0 of radius 2. And so we draw that. The boundary is not included, and so it is dotted. And last but not least, this is an equation, and this is, since the coefficients of the x squared and y squared are not the same, this is not a circle, it is an ellipse. And so you can see that this is the ellipse that you get for part F. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now, more than ever, take care of yourself and of each other. We're all in this together. May God bless you all. More later and soon.